Okay, in this question, part A, we have 4 functions and we need to check which of them are increasing and which are decreasing on the interval 0 to 12. Notice that whenever you have log, whatever is inside log has to be bigger than 0. This is by definition of log. It cannot have inside of it 0 or a negative number. Okay, so now, how do you know if something is increasing or decreasing? We will use the derivative, because the derivative, if it's positive, then the function is increasing, and if the derivative is negative, then the function is decreasing. Remember this. It's very important to remember. And now we will take the derivatives of each of them and check. So what's the derivative of f? F prime is derivative of 15 is 0. Derivative of log is 1 over x plus 1. Derivative of ln x plus 1. Remember, whenever you have ln of anything and you take its derivative, it is just write it down and then take its derivative. So here what I saw this, and when I took the derivative, I just wrote the thing that is inside in the denominator, and then I looked at it and took its derivative. The derivative of x plus 1 is just 1. So this is the derivative of logarithm. Okay, good. So now this, notice, but this is always negative, because x plus 1 is positive and negative 3 is negative. When you multiply negative and positive, always negative. So this function is decreasing. Let's write decreasing just DEC and increasing INC. Okay, now what about this one? Because it's similar, h of x, take the derivative. Let's do it here. H prime of x equals 0 plus, you'll get 3 over x plus 1. And this is always positive. So this function h is increasing. Everywhere increasing. Okay, and now these here, if you take g prime, you'll get 0 and then the minus 2. So when you take, okay, minus 3, the derivative of exponential is the same, times the derivative of the exponent is negative 2. So now, negative 2 times negative 3 is 6 e to the negative 2x, which is 6 over e to the 2x, if you want to see it like this, and see that it, obviously, this is positive, because exponential is always positive. So this the derivative is positive, we showed, and so this function is increasing. Finally, this one, let's see, if we take p prime of x, we will get negative 6 e to the minus 2x, which is minus 6 over e to the 2x. This is always negative, because exponential is always positive and negative 6 is negative. So when you multiply negative or divide negative by positive, it's always negative. And so this is always decreasing. Let us check now the 4 functions if it's true. So I'm going to Dismos now, and we will enter them one by one. F of x 15 minus 3 ln of x plus 1. Okay, so maybe you keep it like this to see the function. You see, decreasing function. Obvious. And the other one is plus. If you put a plus, it's increasing. So that was this function here, and we said it's increasing. Now let's go to the exponentials. So the first one was 15 minus 3 e to the minus 2x. You see, increasing, yes. And the other one is 15 plus. You see, it's decreasing. And so we checked those 4, and we will go now to the second part of this question. And it says, which of the exponential functions below show growth and which show decay? Okay, so remember, if you have y equals p0 not e, let's say a to the t, this is your exponential function. Then if a is between 0 and 1, you say I have exponential decay. If the base, yeah? And if the base is more than 1, you say that you have the exponential growth. And if the base is 1, there is no such thing. So you'll say this is not an exponential function. It's a constant function. It is constant when you have 1 as the base, because 1 to any power is 1. It doesn't change. Okay, good. So now let's look at them. This is, the number here is 2, more than 1, so this is growth. Let's say G means growth, and D means decay. Okay, so let's even put the decay in another color. And look for all the growth first, and then all the decay will be what's left, hopefully. So, do you see any growth? So let me see here. Yes, I see here. This one is 1 plus something, so it's more than 1. What else? So from the ones that we're seeing here, only these two from the first 2 lines. Leave these until the end, okay? Forget about these for now. And look at the other ones. And notice this one is decay because half. The base is half, less than 1. This one is decay because 1 minus 0.15, this will be 0.85, which is less than 1, so decay. And this one, I have to put it by itself. This one is neither growth nor decay. Why? Because 1 to the x, this is always 1. So the entire thing here is always 50. It doesn't change. And so it's not an exponential function. Okay. And now let's, so yeah, we saw, and this one is exponential decay, obviously, because 0.8 is less than 1, so decay. And when I did growth, I should have put a G here, and neither will put an N. Okay, good. You don't need to check them. This is by definition already. So I'm going now to the last line, these ones here. So e to the x, this one is increasing. When you replace x by negative x, when you do e to the minus x, this is the same as 1 over e to the x, which becomes now decreasing. Okay, you can even say that this is equals to 2 times 1 over e to the x. And 1 over e is a number less than 1, and so you have an exponential decay. Okay, now for this one, you have e to the x, which is growth already, but you multiply it by a negative number. When you multiply something by a negative number, it reflects across the x-axis. It becomes like this, the function. And so if it was first increasing, now it's decreasing. So this one here is decreasing. So this one also decreasing. So these first two are, we see they are decreasing. Now the third one, minus 2 e to the minus 2x. Let's do another way to check. Let's do y prime. So it will be minus 2 times minus 2, it will be 4 e to the minus 2x. So if you want to do it in detail, okay, you will do minus 2, and then the derivative of exponential is the same, times the derivative of the exponent is negative 2. And that's why negative 2 times negative 2 gives you 4 e to the negative 2x. And y prime, this is y prime. Notice it's always positive, because this you can write it as 4 over e to the 2x, always positive, so the function is increasing. So I have to put this with the increasing color. So this is increasing or exponential growth. And last but not least is this one. Let's see. This is 50 times 2 to the negative 3 is 1 over 8. to the x. Because you know, 2 to the power 3, 2 to the power negative 3 is 1 over 2 to the power 3, and 2 to the power 3 is 8. And so 1 over 8 is less than 1, and so it's decay. It should be with blue, of course. Our color for decay is blue. So let's check now just this last line in Dismos. Okay, so we will put them one by one. 2e to the minus x, 2e to the power minus x, decreasing, yes. Minus 2e to the x, so now we put minus 2e to the x, decreasing. You can see here it's going down, so correct. Now minus 2e to the minus 2x, so here you'll put negative 2. This one is increasing, it goes up, and we said it's increasing. And last, 50 times this, 50 times 2 to the power negative 3x, decreasing, as you can see. If you want to see it by itself here, obviously it's decreasing like what we expected. And I will stop here.